Hello learners, welcome to this lesson. My name is Teacher Alice and today we are going to look at the second topic of Form 2 work. So the chapter 2 is chemical families, patterns in properties. So this is our part 1. So this is the beginning of the chapter. We are going to look at chemical families. So the subtopic is chemical families, and we say that elements, as we saw earlier in the first chapter, belong to groups and periods. So we classify elements the elements according to groups and periods. So we classify elements into groups according to the number of valence electrons, and also we classify elements into periods according to the number of occupied energy levels. So that is just a reminder. Elements in the same group are said to belong to the same chemical family. Hence, they all have the same or similar physical and chemical properties. So we are going to look at several chemical families. One is the alkali metals, two, the alkali earth metals, 3, the halogens, and 4, the noble gases. So today we start by looking at the alkali metals. So what are alkali metals and which are these metals that belong to alkali, to this chemical family we are calling the alkali metals. So alkali metals, these are group 1 elements of the periodic table. So these are elements that are classified as group 1 is what we are calling the alkali metals. Members of alkali metals include 1, lithium, sodium, potassium, niobium, calcium, and francium. The electron arrangement, so we are going to look at the first 3 elements in alkali metals or in group 1. So these are lithium, sodium, and potassium. So the electron arrangement of lithium is 2:1 because it is atomic number 3. That of sodium is 2:8:1, and that of potassium is 2:8:1 because potassium is atomic number 19. So each alkali metal has 1 electron in the outermost energy level. We have seen that. Therefore, they are monovalent because they all have a valency of 1. Down the group, there's an increase in the number of occupied energy levels. For lithium, we have 2 occupied energy levels. For sodium, we have 3 occupied energy levels. And for potassium, we have 4 occupied energy levels. So that is why we are saying that the number of energy levels are increasing down the group. So what about the gradation in size of the atom and the ion? So we are looking at the atomic size and the ionic size of the alkali metals. So what happens to the atomic size and ionic size, or how do we compare them? So first, what is atomic radii? So atomic radii, or the atomic size, is the distance between the center of the nucleus and the outermost energy level occupied by an electron or the electrons of an atom. So for the group 1, the outermost energy level is occupied by 1 electron. So the distance from the center of the nucleus to the outermost energy level that is being occupied by the electron of that atom is what we are calling the atomic radius. The atomic radii and the ionic radii of the alkali metals, or what we are calling the trend, increases down the group. This is due to the increase in the number of occupied energy levels. So we have seen sorry, for the atomic radii for sodium is larger than that of potassium. So it is smaller, it is smaller than that of potassium, because we are saying the atomic radii, even the ionic radii, increases down the group as there's an increase of occupied energy levels. The atomic radius is bigger than the ionic radius for alkali metals, because if we want to form an ion of these alkali metals, we lose one electron. So this element has to lose one electron. And by losing one electron, it is losing the whole energy level. Therefore, the energy, the ion will be smaller than the atom, because it has already lost one electron. For example, for potassium, the atom has 4 energy levels. Then, if we want to form an ion of potassium, we have to lose the last electron. That means we are going to lose the last energy level to have 3 energy levels that have occupied, that have electrons. So it have 3 energy levels that are there in an ion of potassium. Therefore, comparing the atom and the ion of potassium, the atom is larger than the ion. So we are saying it has a bigger atomic radius than the ionic radius, because they form ions by losing one electron from the outermost energy level. Hence, the resulting ion has one occupied energy level less than the corresponding atom. So that is the reason, or the explanation we give for the larger ionic radius of the larger atomic radius of alkali metals than the ionic radius. So the next thing we are going to look at is the physical properties of alkaline metals. And the first property we are going to look at is ease of cutting. So the alkaline metals have a shiny metallic luster when freshly cut. However, this surface quickly tarnishes. This is because these elements or these metals will react with air. They are soft and easy to cut, so you can just cut it with a piece of knife. You can just cut it into 2 pieces using a knife. The softness and ease of cutting of alkali metals increases down the group. This is because of the decrease in the strength or force of attraction holding the atoms together as the atomic size increases down the group. So as the atomic size increase, there will be decrease in force of attraction. So for example, for potassium, it has a larger atomic size than sodium. Therefore, potassium will have weak forces of attraction than sodium. So it will be easy to cut potassium than when cutting sodium. So that is how the ease of cutting can be explained down the group. So it decreases or it increases down the group. So it is easier to cut the metals that are down the group there than the ones that are at the top. The next property we are going to look at is the melting and boiling points. Alkali metals have relatively low boiling and melting points. The melting points and boiling points of alkali metals decreases down the group. This is due to the decrease in the strength of forces of attraction holding the atoms together as the atomic size increase down the group. So if you are asked to explain why the melting point or the boiling point of potassium is smaller than that of sodium, this is the explanation. You say that the strength of forces of attraction holding the atoms together for potassium is smaller or are smaller than those of sodium. For example, we have one example there. Sodium has higher melting point than potassium. The reason is sodium has smaller atomic radii than, than potassium, and it is held by strong forces of attraction. So the small size of the atom, the stronger the forces of attraction, and vice vice versa. So the next physical property we are going to look at is ionic energy, ionization energy, that is. So what is ionization energy? Ionization energy is the minimum energy required to remove an electron, to remove an electron from the outermost energy level of an atom in its gaseous state. So ionization energy, minimum energy required. This is the energy we are requiring to remove the electron to make it an ion. So during a reaction, there will be loss of electron for the alkali metals. So this energy that is being required to remove that one electron from the outermost energy level of this atom in its gaseous state is what we are calling the ionization energy. The first ionization energy of the alkali metals decreases down the group. The reason is due to the decrease in the strength of the forces of attraction holding the atom together as the atomic size increases down the group. So this is very important. You should know the trend or what is happening down the group and giving the valid reason why that is happening. So the first ionization energy of alkali metals, we said it is decreasing down the group. So for potassium, we have a smaller ionization energy than that of sodium. And we said that the reason is due to the decrease in the strength of forces of attraction. So for example, if you look at potassium, it has 4 energy levels. So the one electron in the outermost energy level is held loosely by the nucleus compared to that one electron in the outermost energy level of sodium. So because it is held loosely, so it is easier to lose that one electron. So it is easier to lose that one electron for potassium. So the energy that is being required to remove that one electron in potassium is smaller as compared to this one of sodium that is being held more by the forces of attraction. So that is how you can argue. So as long as you know the definition of ionization energy, it is very easy to give the reason why the ionization energy decreases down the group or for the alkali metals. So the last physical property for alkali metals that we are going to look at is the electrical conductivity. And we say conductivity for metals happens due to the presence of delocalized electrons in the structure of the atom. So for a metal to conduct electricity, there must be delocalized electrons. And for alkali metals, these are all metals, and they are conductors of both heat and electricity. That means there is presence of a delocalized electron in the structure. The electron that is in the outermost energy level that is ready to be lost, that is the delocalized electron for the alkali metals. Electrical conductivity usually increases due to increase in the number of delocalized electrons. And since for all members of alkali metals have one electron in the outermost energy level, this means they all have similar conductivity. So the way sodium conducts electricity is the same way sodium conducts electricity. So that is electrical conductivity, and that is the last physical property we are going to look at for alkali metals. And for what we are looking, the last thing we are looking at today. So that marks the end of our first part of chemical families. So in our next lesson, or in our part 2, we are going to look at the chemical properties of alkali metals and the uses of alkali metals. So make sure this video helps you. It has good notes, so you can always pause and take down the notes or read the notes so that they can help you answer questions as required. So let us meet in the next lesson, and may you have a nice time.